All right, so I want to take a look at quadrilaterals more in depth. So looking at different types of quadrilaterals. So the reason for this is because sometimes, and actually a lot of times, when people see a four-sided figure, they immediately will say, "Oh, that's a rectangle," or "Oh, that's a square," or "Oh, that's a trapezoid," and have no backing whatsoever other than they just want to call it that. Um, and this isn't said to be um, spiteful or kind of nitpicky. It's the fact that we define quadrilaterals very specifically. A quadrilateral is a four-sided polygon. So if you see a four-sided polygon is a quadrilateral, when you begin to learn more about it, say the measurements of its angles or its side lengths, then you can begin to define it more. If you don't know those things, you can't just shout out that it's going to be, oh, it's a rectangle, or oh, it's a trapezoid, or oh, it's blah, blah, blah. So what I am going to show you though, to begin this, is different types of quadrilaterals, and then we'll get more in depth with them as we move along. So first and foremost, I have this question mark here, and I love to show this to students to start off without the other ones there usually, because usually the answers that I get are trapezoid for this one because they see it kind of slanted but uneven on one side. A trapezoid, as shown here, must have one pair of opposite sides parallel, meaning it must have two sides that are opposite of each other. That if I were to extend them, they would never ever cross. So here, this is a trapezoid because this top and bottom part would never cross. It would always be parallel. And then you have two other sides. That's what makes it a trapezoid. As you can note here, no matter what I do, these will eventually cross if I were to extend its sides. So this is just a quadrilateral. It's not a trapezoid, it's a quadrilateral. Now, from there, we have two distinctions. Are, are the opposite sides parallel, or both pair of opposite sides parallel? Because if just one pair of opposite sides is parallel, it's a trapezoid. If you have no sides opposite parallel, then it's just a quadrilateral in general. But if you have one pair of opposite sides that are parallel and it's a quadrilateral, it becomes a trapezoid. We can further explain what it is based on more given information. Now, let's say we have two pair of opposite sides parallel. Well, then that becomes a parallelogram, and this is the one that most people are commonly are used to seeing because we have parallelograms. We have within parallelograms we have a family of different types. We have rhombus, we have kites, we have I guess I shouldn't say kite in that answer, but we have rhombus. We have a rectangle. We have a square. So we have all of that within the parallelogram. Um, so in regards to quadrilaterals, is very important for you to realize the distinction between these. So first and foremost, a quadrilateral is a four-sided polygon. From there, you then say, do I have at least one pair of opposite sides parallel? If I only have one pair of opposite sides parallel, only one, it's a trapezoid. If I have two pairs of opposite sides parallel, it becomes a parallelogram. Okay. And so we will look at some more distinctions here. Let's start with trapezoid. So in the picture drawn there, this is a trapezoid because we know that we have one pair of opposite sides parallel. Is this a trapezoid? Yes, because it has one pair of opposite sides parallel. Those side lengths are not congruent though, are they? No, one is definitely longer than the other and it's obvious to see. We can continue to draw trapezoids like this all day long. But there is a special case of trapezoids, and that's where its two legs are congruent in measurement. So we have opposite sides parallel, but these two sides here called legs, which we'll talk about later. But if the legs are congruent, have you ever seen a shape where you had two sides congruent? You have an isosceles triangle, and we had an isosceles triangle. It was called isosceles because it had two sides congruent. Well, we have two sides congruents here in the trapezoid. We call this an isosceles trapezoid. Okay. All right. So a trapezoid again is having one pair of opposite sides parallel, but we can further define it further if we see that the two legs, or the two non-parallel sides, are congruent, meaning they have the same measurement. If the two legs have the same measurement, it becomes an isosceles trapezoid. All right? Well, that's trapezoids. Let's look at parallelograms. So for a parallelogram, we have two pairs of opposite sides being parallel. So these are opposite of each other and they're parallel. These two are opposite of each other and they're parallel. We also get something really cool. We then see that these two sides that are opposite each other are also congruent in measurement. And so we get opposite pairs congruent. So that is a parallelogram. Well, what else can we do with a parallelogram? A lot of times people just say, oh, it's a rectangle that's slanted. That's one way to look at it. But the reason people say that is because a rectangle is a parallelogram. Let's take a look at a rectangle. So what makes a rectangle a rectangle? Well, the name rectangle actually means a rectangle. Rect coming from rectify, meaning to make right. So it makes right angles. So therefore, it is a rectangle or rectangle. So it makes right angles. So because it has four right angles, it is a rectangle. Okay, so this is a parallelogram because opposite sides are parallel to each other. Well, in regards to a rectangle, we also see that all of its angles are congruent. Well, what do you call a polygon that has all angles congruent? You call it equiangular. So this will be an equiangular quadrilateral. Okay, are all its sides congruent? No, they're not. That's what differentiates it from a square. But let's see what happens. So this is also equiangular. Okay. What about this shape? In this case, all four sides are congruent. They're all the same measurement. Well, we call that a rhombus. Okay. And a rhombus has four sides that are the same measurement. So it's a quadrilateral with all four sides equal. Well, what do we call that normally? Well, normally we would just call that equilateral. Remember, lateral means side. Like in quadrilateral is four sides, equilateral is equal sides. Okay, so a rhombus is a quadrilateral with four equal sides. What if we were to take a rhombus and a rectangle and get those two people together and they had a baby? Well, we would then get a shape that has four right angles, but also four congruent sides. So it would be equilateral and it would be equiangular. Well, if it's equilateral and equiangular, it's regular. So this will be a regular quadrilateral. Well, a regular quadrilateral does have its own name. We call it a square. It's the most sought after quadrilateral. And a lot of times people want to make things into squares, but it's not always the case. A square only happens if it has four right angles and all sides are congruent. It must be regular. It must be equiangular and equilateral. All right. So there are other special quadrilaterals. There are kites, for instance. So kites are very interesting, actually. And so with a kite, what we end up having is that adjacent sides are congruent, meaning they have the same measurement. Many of you have probably seen a kite flown in a movie or in your own personal life, a normal kite. It's called a kite because it has the shape of a kite. Or maybe it's the other way around. But regardless, that is a kite. So you take your hands, for instance, that is a kite that's formed. The adjacent sides are congruent. So a kite is kind of like the marriage of parallelogram with in a kite, and you get a rhombus. So a marriage between a kite and a parallelogram make a rhombus. Kites aren't really used as much in the field, or at least according to the curriculum for this course. So we're going to stick with just these four: parallelograms, rectangle, square, and rhombus. And of course, the trapezoid and isosceles trapezoid. All right, so those are our types of quadrilaterals that we're going to look at, and we'll get more in depth with each one. I'll see you soon.